Okay, welcome back to quadratic functions. We are going to look at some application problems today. Really fancy way of saying word problems. And I have 6 of them picked out that I want to work out with you so that you can have examples of different kinds that you will face. Okay, so you're going to be responsible for problems involving all kinds of different scenarios like sums of numbers, areas of rectangles, volumes of boxes, even profit functions and profit and revenue, those kinds of functions. And all of them are going to end up involving quadratics. So everything you've been learning about quadratic functions and quadratic equations will apply in these problems. You're going to be looking at maximums and minimums. You're going to be looking at vertices. You're going to be looking at where graphs cross the x-axis or zeros, all kinds of different things. So let's work through examples of each type. And I'm going to be pulling these right from your book. First one, let's look at your book. This is found on page 207. This is number 12. It says, suppose that x represents one of two positive numbers whose sum is 45. Represent the other of the two numbers in terms of x. What are the restrictions on x? Determine a function p that represents the product of the two numbers. For what two such numbers is the product equal to 504? Determine analytically. And then determine analytically and support graphically the two such numbers whose product is a maximum. What is this maximum product? All right, so let's work that out. Starting with assigning some variables, let's let x equal one of the positive numbers. And since they do have to add up to 45, you could say, well, let y be the other positive number. But you could also say 45 minus x is the other positive number. Because like if x were 3, 45 minus 3 would give you 42. So you'd have 3 and 42. And those two would add up to 45. Okay, now your number is positive, which means it has to be greater than 0. 0 is neither positive or negative. So since they said positive, specifically it's greater than 0. And since the two of them have to add up to 45 and they have to be greater than 0, your number also has to be less than 45. I mean, it could be 44.9 and the other one could be 0.1. But as long as it's positive and the two add up to 45. Okay, so that's the restrictions on it. Now, if we want to do a product function of those two, multiply two of them together, multiply x times 45 minus x. Distribute your x, you get 45x minus x squared. So you could write that as p of x equals negative x squared plus 45x. So you have a quadratic function here. Notice that in the quadratic function, your a is negative 1 and your b is 45. With that a of negative 1, that tells you that it's a parabola that's concave down. It's going to pour out water. And your vertex is going to be the maximum point. Okay, so we want to figure out where does that negative x squared plus 45x equal 504? So you've got a quadratic equation to solve if you want to figure out where this product equals 504. So let's see, add x squared to both sides, subtract 45x from both sides, plus the 504, and that'll equal 0. 504, kind of geeky there. I didn't come up with it, but somebody must have been a geek. All right, so we have a quadratic equation here. You can solve it however you want. It did say to do it analytically. I'm not going to worry about supporting it graphically right now. I'm just going to do it analytically. But I'm going to solve for x. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. So we have 45 plus or minus square root of 2025 minus 2016, and all of that's over 2. So we've got 45 plus or minus the square root of 9 all over 2. So 45 plus or minus 3 over 2. So you've got two answers here. You've got 45 plus 3 over 2. So 48 over 2, which will give you 24. And you've got 45 minus 3 over 2, 42 over 2, which will give you 21. Now 24 plus 21 is 45, and 21 plus 24 is 25. So those are your two numbers that give you that that add up to 45. And if you multiply 24 and 21 together, you should get 504. Yeah. And 24 plus 21 gives you the 45. So those two numbers satisfy your requirements there. Okay, then another question was about maximizing. You want to maximize that product. Again, the product function, and you're dealing with the vertex up the top of the parabola there. So if you identify your vertex, you'll be able to figure out your maximums. Remember, vertex has a vertex formula you can kind of use as a quick thing to get your vertex. Negative b over 2a will give you the x coordinate. So if you're trying to maximize the p of x equals negative x squared plus 45x, you have negative 45 over 2 times negative 1. That's going to give you 22.5. And 22.5 plus another 22.5 equals 45. And when you multiply those together, the maximum product is 506.25. So there's that question. Okay, next what I'm going to do is number 16. Area of a rectangular region. A farmer wishes to enclose a rectangular region bordering a barn with fencing as shown in the diagram. Suppose that X represents the length of each of the 3 parallel pieces of fencing. She has 600 feet of fencing available. So the fencing, they show 3 lengths that are the same. They're represented with X. One side of this rectangular yard is going to be bordered by the barn, so you don't have to worry about fencing there. The other side, though, wants to know what is the length of the remaining piece of fencing in terms of X. Then it wants us to determine a function A for the area, giving any restrictions on X. What are the dimensions for the total enclosed region to give an area of 22,500 square feet? And then use a graph to find the maximum area that can be enclosed. All right. So we've got to draw a picture for this geometry question. I'm going to go ahead and call the unknown side y for now. And they tell us she's got 600 feet of fencing to work with here. So these 3 x lengths plus this y length has to equal 600 feet when we're all said and done. So y equals 600 minus 3x. All right. If we want to find the area of a rectangle, that's length times width. So in our case, the area of this rectangular region, we got to do x times 600 minus 3x. So area A of x is going to equal 600x minus 3x squared. Or we could say negative 3x squared plus 600x. So we once again have a parabola that dumps out water. And the vertex gives us a maximum point. That is that at the x value for that vertex, the y is the maximum value, maximum area. All right, and for this situation, x has to be bigger than 0. Because if you had a side of 0, you wouldn't have a rectangle. And x has to be less than what? Well, the total amount of fencing is 600 feet. And you've got to have something for x and something for y. Well, if you just had the 3 x's, then you would need x to at least be 200 feet. But you've also got that y, so you need x to be, you can't have x more than 200 feet because then it would exceed the 600 for these 3 pieces. It can't be equal to 200 feet because then it would equal to 600 and then you'd be missing your y. So x has to be less than 200. So that's our limitations on x. All right, we want the area to come out to 22,500 square feet. So let's see, rearrange the terms a little bit. We can have 3x squared minus 600x plus 22,500 equals 0. Okay, so A is 3, B is negative 600, C is 22,500. Okay, so to find x, we're going to do negative b plus or minus square root b squared minus 4ac, and all of that is over 2 times a. So we have 600 plus or minus square root 36, 1, 2, 3, 4, minus 4 times 3 times 22, 5, which is 270,000, all over 6. So we've got 600 plus or minus square root of 90,000, all over 6. So 600 plus or minus 300, all over 6. You work those out, you get 2 values. You get 150 and 50. Well, y equals 600 minus 3x. So 600 minus 3 times 150, or 450, gives you 150. So one possible dimensions for this would be 150 by 150. Or y equals 600 minus 3x. Using the 50, you got 600 minus 150 is 450. So you could have 50 by 450 for another possible layout for this rectangle. And then if you want to maximize your area, what would you have to use and what would your maximum area be? Well, you can use your vertex to help you decide on that. Let's go to our calculator. Let's put in negative 3x squared plus 600x. Let's hit graph. I might need to change my window a bit. Yep. Let's do this. Let's do z squared, which will square it up for us. No, let's do z standard. Sorry. Let's see here. Zoom. Let's do z standard. That'll actually put it like negative 10 to 10, negative 10 to 10. And I know I'm not going to see it very well, but then when I go to zoom out, it'll be a little better. And then zoom out. And not seeing it yet, am I? Some big numbers, that's the problem. I mean, I could think about what my window should be and do that. Or I can keep zooming out. Yeah, I probably should just like adjust my window manually. Because the zooming out might take a while. It's not always very pretty. Alright, well, let's see here. I know I was dealing with numbers, like with my x's with numbers like 50 and 150 and stuff. So let's just set our window. Let's set it from 0 to 300. And let's let the scale be in increments of 50. And then for the y's, let's do from 0 to, oh, that's looking pretty good actually right now. So we do 0 to 40,000 and do a scale of 10,000. That's not so bad, is it? There we go. All right, so we need to figure out what this vertex is. So we need to do second calc, and we need to find out that maximum number 4. So we need to make sure the cursor's to the left of that vertex. Hit enter. Make sure the cursor is to the right of the vertex. It's telling the calculator where to look for the maximum value. And then yes, go ahead and guess. And there we go. X is 100, Y is 30,000. So if you let X be 100, which in that case, you know, one of the dimensions of the fencing would be 100 feet. The other one would be 300. You'd have 100 feet by 300 feet. And the maximum area would be the y value. Because remember, this is the area function. So maximizing putting the right x in will give you your maximum y or maximum area, which is 30,000 square feet. So the actual maximum value is 30,000 square feet. So that's a little bit about using the calculator, using it graphically to do that. All right. Let's go back to, actually let me go to the book first. Next problem we're going to do together is number 18. Hitting a golf ball. Golf ball is hit so that its height h in feet after t seconds is h of t equals negative 16t squared plus 60t. What is the initial height of the golf ball? How high is the golf ball after 1.5 seconds? And find the maximum height of the golf ball. All right, so let's do it. So we've got this function, which if you study physics, you're going to do a lot of functions like this. H of t equals negative 16t squared plus 60t, where t is time in seconds, h is your height in feet. And initial height, your t is 0. It hasn't been hit yet. So, you find h is 0, and that'll tell you your initial height of your golf ball. Because 0 seconds have passed if you haven't hit it yet. And you get 0. So That makes sense. It's 0 feet off the ground at 0 seconds, the initial height. Um, you, it's kind of obvious with the golf ball. It's like, well, duh, yeah, it's 0 feet because it hasn't been hit yet. But you can have problems where you don't necessarily start at ground level. So then the function would look different than this. And when you plugged in 0, you would get some value back, which would tell you exactly what the height is at initial time there. Okay, then it wanted us to figure out what's going on with t is 1.5 seconds. So at 1.5 seconds after you hit this golf ball, how high in the air is the golf ball? So you plug in 1.5 for t, and you find out what that comes out to. You get negative 36 plus 90, which gives you 54 feet. So 1.5 seconds have passed, your golf ball is 54 feet off the ground. You hit your golf ball, and it's going to take a parabolic kind of path. From here t is 0, and at some point it's going to be 54 feet off the ground. At 1.5 seconds, it's going to be 54 feet off the ground. Now the question also asked us to figure out about the maximum height. So there you're worrying about your vertex. I'm looking back at H of T. Your A was negative 16. Your B was 60. So when you're trying to find that vertex, negative B over 2A will give you the X value or the T value. So negative 60 over 2 times negative 16, and you get 1.875. So at 1.875 seconds, you're going to reach your highest point. And what is that highest point? Well, evaluate H at 1.875. You just plug it in 1.875 in for t, because that is time. That's how much time has elapsed before your golf ball is at its peak. So you figure that out, you work that out, and you get 56.25 feet. So the highest it'll go in the air is 56.25 feet for a golf ball that's the path follows this function. Not all golf balls are going to have exactly that function. It all depends on the initial velocity, initial angle, and so forth of the hit. But if you know the function, then you can work it out. All right. Let's go and look at another problem. Say you have a question like number 22. You have to excuse me, I've been really sick this week, so my voice isn't the same, and you're going to hear me coughing, drinking water, etc. But hopefully I'll be better by the time I do my next recording. All right, a piece of sheet metal is 2.5 times as long as it is wide. It's to be made into a box with an open top by cutting 3-inch squares from each corner and folding up the sides as shown at the top of the next page. Let X represent the width of the original piece of sheet metal. So here's your piece of sheet metal. We're going to represent the length of the original piece of sheet metal in terms of X. We're going to figure out what are the restrictions on X. Determine a function V that represents the volume of the box in terms of X. And for what values of X, that is, original widths, will the volume of the box be between 600 and 800 cubic inches? Determine the answer graphically and give the values to the nearest tenth of an inch. All right, so let's go back to our PowerPoint. All righty. blank slide. Back to my pen. All right, so we have this piece of sheet metal. The width, we're just going to let it represent with X. And we're told that the length is 2.5 times that. Okay, then cutting out squares that are 3 inches by 3 inches. Okay, so when we do that, the dimension this direction for the base of the box, like once you cut out those squares, you're going to be able to fold up the sides and make a box. It's going to have an open top. But along the base of the box, this right here will be x minus 6 because you're taking out 3 and 3 from this total x. And then along the base here will be 2.5x minus 6. So you fold all that up, and you'll have this box open topped. The height will be 3 inches. Your longest part will be 2.5x minus 6 inches. And your shorter part will be x minus 6 inches. Okay, and the volume of a box is found by doing length times width times height. So you're going to have 3 times the x minus 6 times the 2.5x minus 6. You go ahead and multiply all that together, and you can go ahead and write a function. I'm going to leave it up to you to multiply. 7.5x squared minus 63x plus 108. Now that is your volume function right there. And what we're interested in looking at is where exactly is this volume going to be less than 800 cubic inches and more than 600 cubic inches. That's something we have to investigate. Well, as we investigate that, x has to be greater than 6. Because you have a dimension right here that's x minus 6. So you need a number bigger than 6 right here, because you can't have a 0 dimension. Okay, so let's keep that in mind as we go to our trusty calculators. Okay, so I'm going to put in 7.5x squared minus 63x plus 108. If we hit graph right now, we're not going to see everything. We're not going to see the whole parabola. We actually see quite a bit. But let me also go back to y equals, because we really need to see where is this between 600 and 800 for what values of x. And right now I'm not sure. Let me look at my window. Y max is pretty big. Let's make it a little smaller. Let's make it 1,000, and let's let the scale be 100, because I'm looking at between 600 and 800. Okay, and let me let my x min be negative 100. Let me let my x max be 100. That's a little too much, isn't it? All right, how about negative 50? I really want to get a nice picture of this and really see what's going on. And 50, x scale can be 5s, I guess. That's good enough. All right, so we'll go to the graph. So we have this parabola for the 7.5x squared minus 63x plus 108. Y equals 600 is this horizontal line. Y equals 800 is this horizontal line. We need values of x that are greater than 6, so we can eliminate everything over here, because all that's negative. X is negative over here. We need values of x greater than 6. So what we need to do is figure out for what x values was the volume, this parabola, between the 600 and 800. So what x values are this point of intersection and this point of intersection. So let's go to second calc. Let's do number 5. Right now, the cursor's on the parabola, hit enter. Cursor's on that line, hit enter. An x value of 13.3. Then do it again. Second calc, intersect is number 5. It's on the parabola. I need it on the other line, so I'll use my up and down arrows. Enter, enter, and it's 14.7. Okay, so that's what you're looking at there. You're looking at a graph where you have your parabola. The vertex is down below the x-axis, that doesn't really matter. And parts of the parabola to the left of the y-axis. Then we have the y equals 600 and the y equals 800 in here. And we're interested in what's happening here and here, because we need the values of the volume that are between 600 and 800. So when we identified that point, we got 13.3, and that's at the 600 for y. And when we did that point, we got 14.7, and that's for the 800 for y. That's in inches. So when x is between 13.3 inches and 14.7 inches, the volume is between 600 cubic inches and 800 cubic inches. All right, 2 more to go. Next one. It's found on page 209, number 26. Height of a kite. A kite is flying on 50 feet of string. How high is it above the ground? If its height is 10 feet more than the horizontal distance from the person flying it, assume that the string is being held at ground level. Okay, so ground level, 50 feet of string to the kite. The height above the ground is 10 feet more than the horizontal distance from the person flying it. So they went ahead and let the height be x, and they went ahead and said x minus 10 for the horizontal distance. I probably would have said x for the horizontal distance and x plus 10 for this. It doesn't matter though. I'll stick with what the book has, but you could do it either way. All right, so let's do it. What we have here is a right triangle, folks. Back at the beginning of the course, we worked with right triangles briefly with the Pythagorean theorem. And that's exactly what we need here, because we're trying to solve for x. Remember, a right triangle, you can find, if you have two sides, you can find a missing side using a squared plus b squared equals c squared. But actually here, we're missing two sides, and that's okay, because we have expressions we can use for the two sides. And we have that third side, 50 feet. And we can put those expressions in and use that to solve for the missing sides of the right triangle. So you don't not necessarily have to have numbers, but you have to have, at least have expressions to represent each of the sides. So you got x squared plus x squared minus 20x plus 100 equals 2500. Do a little cleaning up. 2x squared minus 20x minus 2400 equals 0. You can actually do some factoring for this problem. Factor x squared minus 10x minus 1200 into x minus 40 times x plus 30. And then I'm going to go ahead and use the zero product property. 2 doesn't have a variable attached to it, so I'm not going to worry about it. But x minus 40 can equal 0 if x is 40. X plus 30 can equal 0 if x is negative 30. Okay, negative 30 does not make sense. We're talking about a height here, so we go with 40. 40 feet. So that kite is 40 feet off the ground. All right, one more question. This one's found on page 210, number 34. When Respect Brings Success charges $600 for seminar on management techniques, it attracts 1,000 people. For each decrease of $20 in the charge, an additional 100 people will attend the seminar. Let X represent the number of $20 decreases in the charge. Determine a revenue function. Find the value of X that maximizes the revenue. What should the company charge? And what is the maximum revenue the company can generate? Okay, so that's page 210, number 34. Right, we're trying to find a revenue function. I'm going to call it R in terms of X. Okay, and revenue, you're looking at, how much money are they bringing in per unit sold, or per, in this case, per client or whatever. They initially bring in $600 revenue for if they for each client if they bring in 1,000, or for each thing sold if they take care of 1,000. So initially, as long as they have 1,000, it's $600 per one. So $600 times 1,000 would tell you how much they'd bring in, if they actually generated 1,000 of them. But for every 100 extras they bring, they're bringing $20 less. We don't know how many of these extras they're going to bring, so we'll let X represent. So for every group of 100, X represents how many groups of 100 we got. The amount they sell it for is going to go down $20. All right, so you work that out, and you get a nice revenue function. Go ahead and multiply it out. I'll trust you to do that part on your own. And you end up with negative 2,000 x squared plus 40,000 x plus 600,000. If you want to talk about maximizing revenue, you got to look at the vertex again. Negative b over 2a will help me to see what the x value is of the vertex. So negative 40,000 over negative 2,000, which will give me 20. Oh, I'm sorry. 2a, 2 times. Sorry about that. Which will give me 10. Okay. So x equals 10 will maximize the revenue. So they need 10 above 1,000. For figuring out what the maximum revenue would be, you do R at 10, and you're going to get $800,000. And how much should they charge? Remember, they charge $600 per person when for the first 1,000 for bringing in 1,000. But this is saying they should bring, they're gonna bring in 10 more than 10 groups of 100 more than that. So it's gonna have to go down by $20 for each of those 10 groups of 100. So they need to charge $400 to maximize revenue. So for each one they sell, they'll charge $400. That will maximize how much money they'll bring in. If they charge more than that, or if they charge less than that, they won't bring in as much revenue. They won't bring in that $800,000. All right, so there you go. There's examples of each type that you're going to be responsible for. Practice, practice, practice. You have a lot of homework problems to do. I would suggest doing all of them so you can get plenty of practice with all these word problems. Thank you for joining me, and I hope I sound better next time.